Welcome to my vSphere material. This is Mastering VMware's vSphere. We're dealing with Chapter 7, Ensuring High Availability and Business Continuity. So this is always a big one because a lot of organizations that I deal with, they'll use things like VMware's vSphere Essentials, and they will ignore all of the high availability and business continuity options, such as things like VMotion. So this is actually a critical chapter because, again, the entire point of virtualization is so you to use less hardware, but it's also about efficiency. Having a scalable environment that, well, can bounce back. When a physical machine dies, how do we recover? And that's the thing. With high availability and business continuity, you can build in some redundancy, you can build in some features so that we're able to recover a lot quicker. So that's always been a huge thing. So we have to understand the different types of clusters and the different ways that we do things. So there are multiple ways to achieve our high availability. And so we have to think about different applications and how that's going to work. So they break it down into four major layers: a physical layer, a virtualization layer, an operating system layer, and application layer, because you can do high availability in each of these layers. So, for example, things like the application layer, we could have the Oracle's Real Application Cluster or Microsoft clusters. Well, Microsoft clusters will probably be more of the operating system layer, but that kind of depends on how we're doing our clustering. Because we can cluster the operating system, we can cluster some of the services, so the Windows clustering need to be more specific. If we're dealing with server failover clustering, then yeah, that's an operating system layer. If we're dealing with virtualization, that's going to be the high availability and fault tolerance. So what's the difference between high availability and fault tolerance? That is a really good thing to understand because that's normally an exam topic. So one of the big ones is how it deals with high availability and how it deals with fault tolerance. Fault tolerance, in some cases, can see that a fault is coming, and so it will spin up a second instance of the same VM on a separate host, and then migrate quickly between the first and the second hosts. That way, the actual downtime is very minimal, where high availability sometimes has to be able to restart a VM, not actually do the migration itself. So there are some differences. Fault tolerance will do live migrations, so do keep that in mind. What about redundant within hardware? Because that physical layer is still really important. So we could have redundant NICs, redundant host adapters. We could use centralized storage. That way the VMs aren't stored on any individual host. That way if a host does go down, we can use software like VMotion to quickly spin up the VM on a different host. Redundant power supplies, redundant processors, redundant memory. Pretty much you can have redundant everything when it comes to the physical layer. So the two main clustering technologies that we're talking about in Windows is the network load balancing and the Windows failover clustering. And actually I have both of those as labs in a 7412 playlist of mine. So let's talk about vSphere's built-in high availability. Again, the high availability is designed to provide an automatic restart of the VM. So it will actually restart those VMs on a separate ESXi host. Notice I did not say live migration. It actually will power back on a VM on another location. vSphere 6 high availability uses a service called the Fault Domain Manager, or FDM. It can use something like a master and slave architecture or primary secondary, things like that. They both use management networks and storage devices for its communication. Some actually will use a heartbeat or another type of beat or specialized packet, letting them know that they're all active. Addresses is the issue for both networking partition and the network isolation, so that becomes kind of an interesting concern. So here we have the master, and its primary responsibility is things like monitoring both the slave host, monitoring the power, and managing the list of hosts that are part of members of that clustering. So it's about management. It also keeps manage of the appropriate protected VMs. It also manages the cache of the cluster configuration. The master actually will take the cache and then it will actually dish it out to the appropriate slave hosts. If there is a configuration change to the cluster, it's all essentially managed through that master. The master also sends the heartbeat messages to the slaves. That way the slaves know that the master is alive. If the slaves do not receive a heartbeat from the master, an election process should occur, and then they'll elect a new master. It also deals with things like reporting the state information to vCenter. And what's really interesting is it can also restart vCenter if there's an issue. So I kind of already spoiled this next slide, which actually is the high availability enabled cluster will elect a master. If the master that they did elect no longer is responsive, they redo the election. All hosts become a slave, and then the slave's responsibilities are to watch the runtime states of the VMs running locally, to monitor the health of the master, to implement the vSphere high availability features that don't require central coordination, such as like the health monitoring of the VMs. So the nice thing is with high availability, we're able to resolve certain key issues. VM options, VM monitoring, data store heartbeats, and admission controls. Basically, the admission controls are going to be more of a who's allowed in. Oh, sorry. I started talking about it before I changed the slide. So should the vSphere HA high availability allow users to power on more than VMs? What about if it doesn't have the capacity to? So that's kind of interesting. Should the cluster prevent more VMs from being powered on than it can actually protect? If it knows it has X amount of memory and X amount of processing power, and it will allow for bubbling of those resources or ballooning of those resources actually. So that is definitely a concern when it comes to high availability because, again, being able to protect the VMs, understanding how the ballooning affects the protection, that plays a huge part of this. So VM options, restart priorities. This is kind of important. So sometimes you may have a beefy server and it may be running 20 VMs. Do you start all of them at the same time? Can that lead to issues if you do? Can we set it so that instead of starting all 20, we have a priority list? Maybe you let it run certain VMs first and others later, depending on how you want to set this up. So high availability does have a lot of options when it comes to priorities. So make sure to understand them. Isolation response. So what do you do when a host becomes isolated? It hasn't failed, but it's not really responding. Should we leave the VMs powered on, powered off, migrate? What? So you can actually set some of these options. You can also deal with monitoring. So the high availability can also look for guest operating systems and application failures. That way, maybe the VM is running, but maybe Windows has crashed. And so the VM is still running, but in reality, it's not really running. So you can have it detect that an operating system failure occurred and then get it restarted. Data start heartbeat, we already kind of talked about, not a super in depth, but a little bit. This deals with communication through shared data stores. when the ESXi management network is not available. So let's assume that we have like a management network that's also acting as primary data network, and you also have a VMotion network, and you also have a iSCSI network. Well, the data store heartbeat will be allowed to send those heartbeats through iSCSI instead of through the primary data network. Okay, so moving on to the next part. Just kind of weird that they didn't do part 2 here, but so part of the fault tolerance is the next major feature. So high availability relies on restarting VMs in order to provide that high availability. What if the application which you need is a higher level of availability? That's where fault tolerance comes in. It doesn't just restart VMs. It actually allows you to do the migration. So fault tolerance does provide zero downtime, zero data loss, and in general circumstances, continual availability. So vSphere 6 implemented the SMP fault tolerance that allows you to protect VMs with up to 4 virtual processors, as opposed to earlier versions which were less processor types. Fault tolerance uses newer technology called fast checkpoints to scale beyond a single virtual CPU. Okay, so essentially the big part here is an earlier version, you could only scale 1 or 2 virtual processors. Sorry, I believe in vSphere 5, 5.1, and 5.5, it was a single virtual processor. And so that meant as it detected a failure occurring, it would spin up a VM on a second host, but it only have one processor. So if it was heavy CPU intensive, you're limited by that. The big thing here is fault tolerance doesn't rely on restarting of a VM. It deals with actually loading a second copy of that VM on a separate host and then doing a migration. So when enabled fault tolerance, something like VMotion, you will actually be able to have the VMs loaded on both ESXi hosts. It's processing on one while it's loading on the other. Once the new version of the VM is loaded on the second ESXi hosts, then it actually seamlessly fails over to the newer copy. There is a logging connection between both so that everything is still kept in sync. That way you're not worrying about losing any data. So in the 5 series, one virtual CPU, memory virtualization wasn't supported. In 6 it is. Disk format, thin or thick. The VMDK redundancy is now supported. Though required bandwidth is kind of subjective, because fault tolerance does still work with a 1 gig connection, though it recommended that you normally have 10 gig. DRS is partially supported. And again, the protected and the para-virtualized devices you can go through. The protected VMs and protected hosts are 8 virtual processors. So there are a few important notes. If the guest operating system in the primary VM crashes, the guest OS in the secondary VM is also going to crash because they are identical copies. So do keep that in mind. There are 3 high-level methods of backing up VMs: running a backup agent on some sort of guest operating system, leveraging the vSphere snapshot and the vSphere storage APIs for data protection. This is normally known as VADP, or using an array-based snapshot integration. Normally, I do a combination of all 3 of these. I have backups running on the VMs. I have the snapshot availability, and on the SAN that I centralize, I also have that doing snapshots on the SAN. Yes, storage overhead, but when your VMs are critical for your organization, it's worth it. So running the backup agent within the Yes operating system does have a few drawbacks. Network traffic typically runs across the network. Separate backup networks are important. Backup agents are individually running. So this is, again, overhead. I use something like Semantic that will actually back up to a local drive. It can also do a network backup, but I normally have the backup agent on the host actually doing a full backup on the host, and then I'll have it save it to like an additional storage. So for example, with Semantic, I have it backing up the primary operating system drive, and I normally attach a data drive. I attach a third drive just for backups. And the backup portion is actually located on a different SAN than my data is. That way, I have complete backups of both its operating system and the data. And these are ran regularly. The VMware Data Protection, VADP or VDP, could also be a disk-based backup. And again, it's normally bundled with vSphere and above. It's integrated within vCenter to enable centralized and efficient management of backup jobs. This is really important. You have to have Essentials Plus or above. vSphere's replication, source and destination between multiple data centers, that's been a huge thing. That's actually the last part of this chapter. I want to thank